tech startups because I believe that startups should, not every startup can become unicorn and neither should it. Only deep tech startups have a possibility to realize this fulfilling enlightenment that we see. These are pathways that Google offers, to which I came to glance. Looking at the independent variables, negative variable and positive variable, independent variable, pH, temperature, permeability, Newton concentration, particle size, microbial strain, oxygen levels, effect. These are mediating and moderating variables. The how and when, and then dependent variable. We are looking for metal extraction, using rate, microbial load density, consumption rates, and redox temperature to get affected using different variables. Usually in a lab test type of scenario, you will tweak to balance all of those variables. Now in silico, we are able to prophesize this very easily. I developed a hypothesis based on the variables. The foundational literature review. These are the founding pillars. These are the papers that we have. Essentially what happens, there's a microcosm of bacteria present in a bioreactor, which helps us to do this. One of them is Bacillus ferocitans, Leptospira ferocitans. This will act on the Fe ions, ferrous ions, and leach it, and the new protein sequences, DNA sequences, enzymes will be acting on it, and that can be used to extract the heavy metals. This is environmentally friendly, low cost, highly selective, supports circular economy, has the G20 possibilities of other contaminant feature is a possibility. Challenges are its slow leaching rates, toxicity of pH microbes, process scale up, environmental economic viability. We also look into possibilities where the microorganisms are become into strains which are capable of handling themselves into optimum temperature which is higher than usual. So these kind of challenges have also been dealt with. Unpacking the e-waste, what I am calling as, there is something known as pregnant lead solution. Rather than that, I am going for project Hiranyagarbha, where I am collecting all the scrap through Safai Mitra Seva Yantra or Safai Mitras, and they will be able to identify it from homes, collect it directly rather than putting it into landfills. It will already be given to us. This is the contents of the usual contents that you might find: 63 metals, materials, plastics, other materials, and yes, not just metals, plastics, and other materials such as glass and wood. The possibilities will be acted upon, and some other substrate will be obtained. Divine Yagna, the Buddhas is enraged, Dhanas of Shivas, because the microorganisms are small, I'm calling them Dhanas of Shivas. The Yagna Buddha, because it's a Bharat scenario, Viksit Bharat and Atmanirbhar Bharat solution movement. We're going for a Yagna Buddha, the direct critical call is Yagna Buddha, Divine Yagna is Trishula of Shiva, and the fruit of the Yagna, Lakshmi, you can extract gold or nickel, cadmium, all sorts of things like that. Heat management, Kalchakra, Lakshana, high levels, takes up bio-radiation. Looking into the present scenario of Bharat, how we can project these ideas and market it to a reality which is the possibility of $1 trillion scale. Because that is the goal over here. Nvidia has grown in stock price since 2019 from $19 to around $200 in the past GTC. So $4 trillion plus its market cap will become. Biometallurgy will be used for semiconductor industries to power data centers for AI in the future also. Upfront cost, we got the earthwork side, OPEX, power, reagents, labor, maintenance, large scale. So we are looking towards large scale as in full heat mining, where quarries and everything has been looked at, right? It is costing around $500 million to $1.5 billion. It's a rough estimate right now, using G20 possibilities of critical minerals and all sorts of things. G20 nations, as you know, these 20 nations hold around 85% of the global GDP, with the advent of the African Union also getting into play with them. And the African Union, as you know, has been heavily being used for mining all sorts of purposes. Heat pile leaching and stirred bioreactor. So heat pile leaching is for the entire low grade ores and fly ash and tail minings and all sorts of things. If you want to do it in smaller batches, it will run you into a lesser cost in a laboratory kind of situation where you have to construct it. So, CRISPR, metabolic engineering, enhanced organisms, AI-driven screening, this is how the process will look into. Biohydrometallurgy, metallurgy as opposed to pyrometallurgy. There won't be acid leaching. It is environmentally friendly because microorganisms are the end result of what happens in a leaching site or biomining site is essentially being taken out with the biohydrometallurgy process, looked upon and acted clinically. So it delivers better results. There is no combustion, no loss of syngas, all sorts of things. happens that one tries to attract, but the efficiency of the plants is very low and poor. So we're moving away from all of that. Next. The electrowinning process, essentially you have the AC-DC DC electrode, and then it will just, a normal electrowinning process, it will suck up the metal ions towards it, and it will act like that. Powered by solar energy, so that also is a green possibility for us. The Mukhya Ganas, it listed the Ganas that are acting, and the lithium low grade or green to lithium and so as a possibility. 1 parts per million equals 1.1%. So you can understand the scale at which it is happening essentially. Next. 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 Go. 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 Yeah. Come back. These are the gene sequences that are present. So wild type is being presented. Next. All the metals and every gene sequence is being given. Right. This is a synthesis. This is a 3D rendering. Usually look next. It will look like this. And go ahead. So we're getting a PLDT score of around 90 to 85% and plus amongst all these gene sequences. So it has reduced the time from 2 to 4 weeks to 1 to 2 accelerated timeline. So 10 to 17 weeks it comes to 4 to 6 weeks. Right? And these are the possibilities I have worked with. Right? Each of you might want to know. You are capable of getting this evaluation done in this front. And these are the defect startups. So we're looking at somewhere around $5 billion or a multi-billion dollar possibility to enhance Viksit Bharat, make America great again by Donald Trump is also going on, energy sector is being put up. All sorts of key players coming to play in the G20. That is what has been done by the team.
What data have you used for this particular study that you have done some
yes.
lab experiments?
NCPI, it was done all in silico. So collab fold was used. AlphaFold 2 and AlphaFold 3 papers are given by J. Abramson. Before it was done by John Jumper and Dennis Assadis. Both have won the Nobel Prize in Chemistry previous year in AlphaFold. And this was done through the National Center for Biotechnological Information, DNA Data Bank of Japan, and European Nucleotide Archive. Already have the gene sequences, the wild types. Suppose 173 number in the gene sequence is that you want to change it from cysteine to uracil to try what happens, or some other determinant. So that is what is being done. The lattice, the gene sequences that I have shown.
Those are from which software? The gene sequences?
AlphaFold. No, the data bank already exists. It's publicly, it's a non-commercial possibility that happens when it comes to AlphaFold. Everything has been publicly released for the well-being of the cosmos. And the impact that it has is on the critical level, the SCST communities or the African nations where there's a lot of the liberation happening due to armed forces. That can be resolved.
In the end, you showed some slides.
I work with the government people.
What is the? Why did you bring that over here?
I worked with them. I went to the president of Bharat, member of the Rajya Sabha. By 35 is the youngest age to be the president of the governor, all sorts of possibilities. So I worked with them.
Acetyltyrosine is peroxidase.
Yes, sir.
We have isolated the bacteria and the bacteria is in
Yes,
our
sir.
unit.
Yes, sir. It is in traditional biohydrometallurgy. Using AlphaFold, we are looking into strains which will change the enzyme sequences or pathways, and it will be a new sequence using CRISPR and Cas9 technologies. We will be able to create a new microorganism which will then help us reach environment.
We have done
It can.
it has been tried.
I have actually done a bibliography also. This study is being conducted now, presently. It is a very new and novel pathway. There's a research.
No, there are numerous pathways.
Yes.
But one pathway because acetyltyrosine was not available in India,
Yes.
we thought of procuring it from US. But it was costing more than 1 lakh.
Okay.
Then we thought, why don't we isolate ourselves?
Yes.
My research scholar went to northeastern portions in NASA. And then we brought the samples. We could isolate it and we have it in our
I'm from Madhya Pradesh. I grew up in Madhya Pradesh. So mine area is over and all sorts of possibilities where extremophilic or acidophilic conditions exist. You have to go and search over there where acid leaching or such possibilities are already occurred. And if you collect samples,
There is one situation there where it becomes toxic.
Yeah, it is toxic.
Iron will become toxic to the bacteria.
It may. Though the strain has been developed so that it operates at not at 30-35 degrees centigrade, at 55 degrees centigrade, and it is more resistant rather than the wild type.
No, there is something called we observed that. I'm just giving you the clue.
Yes, sir.
And instead of G20, you can G20 of course Brazil is there.
Brazil presidency is over. South African presidency is going
Even
on.
BRICS like you can take there. Because in Brazil there are a lot of bigger reactors.
Now South African presidency is also there. There's a university in Cape Town which doesn't. I am also going for a internship over at the University of Montana, Leuven. Leuven is very focused on metallurgy.
With the knowledge that I have,
Yes.
only large scale reactors are being operated only in Brazil.
Yeah, these like Mint, Geomines, Alta, Backup, they are all developing these techs. Suppose in Australia, Mint is doing. It need not be an industrial site. It can be part of a residential or a commercial complex itself because there is no emissions that are going to be found using this technology. The reactor does its own thing, and also the reactor can be made not just through steel, and a biofilm can be created by the same bacteria and the microcosm, and the biofilm helps us to increase the longevity of the reactor itself. That is also something that I do with plug flow, still time, continuous flow, all sorts of possibilities are also being looked at as to how to optimize the process. Yes. Thank you. Any questions?